Hello there. In this video we're going to go over some of the basic properties that are associated to exponents, which are going to come really in handy when we start talking about exponential functions in grave detail. So recall the expression x to the power 5 is equivalent to x times x times x times x times x, where we multiply x by itself 5 times. So we're going to start with this concept and extend this to more general values that you probably are already familiar with, but we're just going to be pretty much just reviewing the basics just in case you forgot. Alright, so we're going to begin by deriving our first property for exponents, and that's what some people call the product to sum rule. Alright, so we're going to be letting a and b both be natural numbers. So I'm considering the numbers 1, 2, 3, 4, and so on. Alright, so let us assume we want to multiply together x to the power of a times x to the power of b. So using our definition, this is just going to be x times x times x, this is a times, and then times, so that's that times, x times all the way down to x, and let's assume this is b times. So there's a x's here, b x's here, therefore there are going to be a plus b x's there. So that means this expression is the same as x to the a plus b. So therefore, if we multiply two expressions with the same exact base, we can just add up the exponents together. So this is the first basic property. And this is clearly true where a and b are both natural numbers. So as an example, if I have x to the 7th times x to the 5th, this is the same as x to the 7 plus 5, which is equal to x to the 12th. Alright, so let's work on our next property. So what if we have, say, x to the 5th divided by x cubed, right? So what is the quotient rule for exponents? So we know we can rewrite this as x times x times x times x times x all over x times x times x. Clearly there's three x's, which is a common factor of top and bottom, so they can cancel. So we're just left with x squared on top over 1, right? So how can we quickly get from 5, 3 all the way to 2? Well, that's just 5 minus 3. So one may be able to justify or claim that x to the a divided by x to the b is going to be equal to x to the a minus b. Now let us assume we have something interesting here. So as an example, suppose we have x cubed divided by x to the 5th, where it's sort of reversed. So as we see, we have x times x on top, we have x on bottom. So if we cancel out the three x's that we have here, so we're just left with times 1 on top, so left with 1 divided by x squared, right? So we have this expression. Now what if we apply our rule to this expression? So if that is the case, that means x to the 3 minus 5 is the same as x to the negative 2 is the same as 1 divided by x squared. So now we have another rule that is often used. So let us assume, so we have three rules now. So x to the a times x to the b is equal to x to the a plus b. We have x to the a divided by x to the b is equal to x to the a plus b. And let's assume that a is not equal to 0 here. And also we have this property that x to the minus a is the same as 1 divided by x to the power of a. Again, x does not equal 0. Cool. Alright, similarly, we're going to use these properties to develop some more. So example, suppose we have x to the 5th divided by x to the 5th, and let's assume x does not equal to 0 here. Alright, so if that's the case, then this is going to be x to the 5 minus 5, which is equal to x to the 0. And if we replace x with any number, we have the number divided by itself, which is 1. So therefore we have x to the 0 is equal to the 1, provided that x does not equal 0. Now, I just want to point out something that some people tend to misquote or misunderstand. Let's assume that x actually does equal to 0. So we have 0 to the power 0 divided by 0. So if that is the case, if we apply the same exact rule, we're also going to get 0 to the power of 0, right? If we just replace all of these things, right? Because this is the same as 0 to the 5 minus 5, which is 0 to the 0, right? So all of these expressions, 0 divided by 0, 0 to the 0 power, all are undefined. If somebody says it's 1, if somebody says it's infinity, they're wrong, right? So it does not equal to 1, it does not equal to infinity, or plus or minus infinity, or anything like that, right? So if you hear any of these things, just ignore them. They are undefined. And in another video, we actually go through the explanation of why this is so. Alright, so let's look at our next property. X to the a all to the power of b. So this is the same as x to the a times x to the a times x to the a times x to the a, where I'm multiplying x to the a by itself b times. Right? So I can use my product rule, right? So this is going to be x to the a plus a plus a plus all the way down to plus a. Keep in mind I have b, a's here. So this is the same as x to the a, b, or a times b. So when you have a power to a power, you multiply those values. And this is clearly true for a and b natural numbers. Right? So if we have x cubed all raised to the 7th, this is the same as x to the 3 times 7, which is x to the 21. Alright, so that's another exponent rule. Alright, so let's look at another expression. Suppose I have x, y, all to the power of n. So this again is the same as xy times xy times xy times xy times all the way down to xy. Again, I have n of these. Let's assume n is a natural number. So we can rewrite this as x times x times x times all the way down to x if we want, and then y times y times y times all the way down to y, assuming n is a natural number, where we have n of these and we have n of these. So that means this is the same thing as x to the n times y to the n. And remember, we cannot combine these and say this is x to the y to the power of n plus n, which is xy to the 2n. No, that's not right. Alright, so what exactly are we doing here? So if you have multiplication between two variables, pretty much what we're doing is we're distributing this n to each of the terms in the middle, right? Now, there is a common mistake that I do see a lot of people see. If we have x plus y to the power of n, some people try and use that rule here. They try and distribute this, and this is equal to xn plus yn, right? This is actually not the case. Only if x or y is equal to 0, right? Remember that x plus y to the n actually, x plus y to the n is equal to the sum from k is equal to 0 to n of n choose k times x to the power n minus k times y to the k, right? This is the true expression for x plus y to the n, right? And this is the binomial theorem, which we talked about when we started talking about polynomials and such. So if you haven't learned the binomial theorem, I definitely suggest you check that out. Very useful property. Alright, so similarly, if you have something like x divided by y to the power of n, similarly, this is the same as x. Well, we can rewrite this as y to the negative first times x, right? And what we can do is we can multiply or distribute this in, since we're working with multiplication here. So this is the same as y to the negative first to the power of n times x to the power of n, right? Remember, we have a power to a power, so we can multiply those two things together. So this is the same as y to the minus n times x to the positive n. So, using our properties of exponents, if it's a negative, you can pretty much reciprocate that. So this is x to the n divided by y to the n. So if you have x divided by y, division, what you can do is pretty much distribute this n to the power of the top and bottom. Almost like the multiplication rule. So let's just work with a few examples just to summarize all of these things together. And of course there are other more intricate details, but I'm going to save them for the next video. So suppose we have negative 3 x to the minus 3 y squared all to the power of 4. So notice we're working with all multiplication, so I can multiply or distribute this 4 to the power of y, x, and -3. Remember, -3, let's treat it as an x, a quantity, so I'm going to raise that to a power of 1. So I'm going to multiply 4 by 1. So this is going to be -3 to the power of 1, all to the power of 4, x minus 3 to the power of 4, y squared to the power of 4. So power to a power we multiply. So this is just going to be equal to -3 to the power of 4, x to the power of -12, and then y to the power of 8. So -3 to the 4th is going to be 81. Then we have y to the 8th. And since this is negative, I'm going to reciprocate that and put that on the bottom. So this is going to be my final answer, using positive exponents only, which a lot of people prefer. So let's consider this example. -2 times x to the 5th, y to the -3, all over 3 times z to the -2, all raised to the power -2. Alright, so what I'm going to do is I'm going to distribute this -2 to the -2, the 5, the -3, the 3, and the -2. So this is going to give me -2 to the -2, x, 5, -2, y, -3, -2. And I'm just showing on my work here. You definitely could skip a step if you are comfortable with it. Right? And then I'm going to use my power to a power rule. So this is going to be -2 to the -2nd. I'm going to leave him as it is for the moment. X to the -10, y to the 6th, 3 to the -2, z to the power of 4. Everything with a negative exponent I'm going to reciprocate, so the stuff on top is going to go to the bottom, and the stuff on the bottom is going to go to the top. So this is going to be equal to 3 to the power of 2, y to the 6th, all over -2 to the power of 2, x to the power of 10, z to the power of 4. 3 squared, as we know, is equal to 9, y to the 6th, all divided by -2 squared, which is 4, x 10, z 4. And that's my final simplified answer, using positive exponents only. So this is just an introduction to the properties of exponents, and a couple of examples to illustrate that. In the next video, we're going to get into more intricate examples where we sort of extend these properties associated to natural numbers to all real numbers. Hope you enjoyed.